Two major color systems are used in art and design. Additive color is created using beams of light. Red, green, and blue, the familiar RGB on a computer screen, are the primary colors in this system. Many additional colors can be mixed from these primaries. Subtractive color, on the other hand, is created when white light is reflected off pigments or dyed surfaces. Subtractive primaries are for printing, and they are cyan, magenta, yellow, and black. In painting, we will be relying on a far more diverse range of hues. When white light passes through a prism, it is refracted or bent. This creates a wide spectrum of hues, which is dominated by Roy G. Biv, or red, orange, yellow, green, blue, blue-violet, and violet. Each separate color is defined by a specific electromagnetic wavelength, with red as the longest and violet as the shortest. This is additive color, and for our purposes here, simply means color added by light. For this course, we won't need to focus too much on additive color, as it is subtractive color as the main branch of color theory used in painting. When white light hits a colored surface, some wavelengths are reflected while other wavelengths are absorbed. As shown here, a red surface reflects red wavelengths while absorbing the blue and green wavelengths. Similarly, a green surface reflects the green wavelengths while absorbing the red and blue. All wavelengths are reflected off white surfaces. All wavelengths are absorbed by black surfaces. Color reflection absorption are rarely total. As a result, we can see hints of various colors within a dominant color. The color which hits our eye is referred to as local color. Subtractive color relies on the light that is reflected into the viewer's eye from the pigment used in paint. Each pigment or dye used is chemically unique. Quinacridone red and phthalo blue are transparent and intense. However, cadmiums and earth tones are generally opaque. Many pigments have overtones. For example, certain crimsons are red with violet overtones, while scarlet is red with orange overtones. Other paints, such as black and white, are considered achromatic, which have no hue. Mars black here is shown having very few overtones, while bone black leans a little towards the red spectrum, and carbon black leans a little towards blue. There are three components that artists consider when working with color. They are hue, value, and saturation. Each can be controlled and will have a significant impact on how they may be viewed. Hue, chrome, chroma, and color are all names for the same thing. Hue is the actual or proper common name of any given color. Today, those words are interchanged frequently. The term color tends to be more universal, while hue tends to be more specific and refers to a color found in the spectrum or on the color wheel. For our purposes, the specific placement of hues along the circumference of the wheel will help illustrate the relationships or harmonies. First, each hue is spaced an equal distance from each other. A color wheel can have as few as 6 hues and then doubles itself as more hues are distinguished. The next and more commonly used would be the 12-step color wheel, but you could also have a 24 and 48-step version as well. Color wheels must always have an even number of hues, and that number must always be divisible by 3. Any other combination would not be a true and accurate color wheel. The color wheel is comprised of 3 primary colors, or primaries: yellow, red, and blue. Primaries are so named because they cannot be broken down any further and are the principal ingredients that make up all other colors. If you mix equal parts of 2 primary hues, a secondary hue is created. There are only 3 secondaries: orange, green, and violet. Blue and yellow make green, blue and red make violet, or purple, and yellow and red make orange. If a primary and secondary hue are mixed, an intermediate or tertiary color is created. On the standard 12-step color wheel, there are 6 intermediaries: yellow-orange, yellow-green, blue-green, blue-violet, red-violet, and red-orange. Complementary colors are opposites on the traditional color wheel. When mixed, they can lower intensity and produce a wide range of browns. When paired in compositions, complementary colors become ideal partners. Each increases the power of each other, and each complementary pair has its own distinctive strength. Violet and yellow provide the widest range in value, while orange and blue provide the widest range of variations in temperature. Red and green are the closest in value and create extreme agitation when placed side by side. By mixing two complements plus black and white, we can create a full range of colors that begin to suggest the power of a full spectrum. Color temperature. The color wheel can be divided into two basic areas or groups of warm and cool hues. The warm range is comprised of yellow, orange, red, and some hues of green. The cool hues normally include everything from blue-green to various forms of blues and violets. However, there are few absolutes when dealing with color. Color is relative and will change depending on the other hues placed next to them or in proximity, as we will see in color interactions. Each hue has its corresponding or related value. Value here meaning darkness or lightness of a hue. This is known as inherent value. For example, red has a darker inherent value than yellow, while blue has a darker inherent value than green. Values can be changed or over-adjusted as needed, and more white or black can be added as required. By adding the blacks or whites as required, we can devise tints, tones, and shades. A tint is a hue plus white. We often think of tints as pastel colors, soft and full of light. Tones are a shade plus gray. The base gray mixed with the hue can be very light to extremely dark and everything in between the full range. Shades are the result of mixing black with the hue. You can vary the intensity of the shade depending on which type of black paint is used in creation. Ivory black creates a transparent warm shade, while lamp black will produce an opaque warm shade. On the other hand, Mars and oxide black produce cool shades, so even in something as simple as this, there can be great complexity. As we can see here in this slide, we will start with a base red hue. However, if we mix white into it, we make a tint. The result is pink. And when we mix it with black, maroon is the result. However, these are all still red, and the hue has not changed and remains consistent. The only thing that has changed is its value. The final component of color is saturation, or the intensity and purity of the given hue. Another way to think of saturation is as brightness or dullness of a color. Brighter, more intense colors usually denote a pure saturation of the hue. Tints, tones, and shades will inherently desaturate the pure hue. Achromatic neutrals. Opposite hues, black, white, and grays are considered neutrals and do not appear on the color wheel. These are also known as achromatic. Neutrals can also be created through the combination of complementary colors. These are your optical grays. Artists can use neutral colors to create an illusion of shadow and distance. Optical grays can also be used to create shadows in an image. If two complements are mixed, they will result in a neutral. Unlike achromatic grays produced by adding white to black, artists can use this process to develop either warm-based grays or cool-based grays. Near-neutral colors have low saturation, but because of the hue undertones, the color is not a pure neutral. Darker or lighter neutral colors help create a realistic-looking lighting effect. To create an illusion of depth, artists paint the item in the distance with less saturated or a neutral color. Atmospheric perspective is a method of using color to create a spatial effect. As objects move further away from the viewer or foreground, they lose color. These objects become desaturated as they recede in space, and the further back the objects are from the viewer, the less texture and detail will be visible. Color harmonies, colorways, and color schemes are all different terms for the same thing. These are ways in which artists and designers pick and use a combination of hues, knowing that they will work easily together in a composition. These harmonies can be seen easily in the relationship to each other on the color wheel. These relationships show the importance of why these hues are placed in the circular format that they are. Closely associated colors are called analogous color schemes. An analogous group is any three hues directly next to each other on the color wheel. In the 12-step color wheel, yellow-green, green, and blue-green are all analogous. As the color wheel gets larger, the range within analog color groupings can become much more limited. In some large wheels more than 12 steps, the range is sometimes increased to 4 hues next to each other. The key to analogous color schemes, however, is that they are always next to each other. This color scheme has the least amount of contrast. Because these colors are also so close in hue, they almost seem to blend into one another. This effect can be seen in Rothko's painting here, where the artist used orange, yellow orange, and red orange to create this harmonious effect. As we covered earlier, two colors that are exact opposite from each other on the color wheel are known as complements. They present the highest form of contrast within the color wheel. If the hues picked are equal in value and saturation and they are placed next to each other in a design, the colors will appear to vibrate. They will also be brighter and more intense, and this is known as complementary contrast. Complementary contrast is a reaction in the viewer's eye and not with the actual pigments. It's one of the many forms of color interaction. They should also be thought of as a balance between warm and cool colors. In any complementary pair, one hue will be warm and the other one cool. The Impressionists and Post-Impressionists were masters of the use of complementary pairs in their works. Here, Sandy Skogland uses complementary pairs to highlight the oddness of this scene. Two hues directly opposite each other on the color wheel are the most simple and fundamental uses of complementary colors, but there are more intricate and elaborate variations. In a split complement, instead of selecting both opposites, one end is selected and the other end is two colors adjacent or picked, depending on their relation to the complement. This schematic will resemble a Y shape. The additional color gives an artist more material to work with and allows for more complexity. Here in Van Gogh's Self-Portrait Pipe, Van Gogh used a split analogous color scheme to highlight the green in his coat and add more variety in the color scheme. Triads. Like the name implies, a triad is composed of three hues. Each of these hues must be of equal distance from the other on the color wheel. Another way for us to remember the makeup of a triad is to think of it as an equilateral triangle placed inside of the color wheel. Each color touched by a point of the triangle would represent a hue. The most common and simplest form of this color scheme would be the three primaries, or the three secondary hues, but intermediate hues can also make up a triad. Here we see Roy Lichtenstein using a triadic color scheme to evoke the pages of a comic book. The triadic color scheme is harmonious, but also adds some dynamic elements to his composition. Tetrads. If a square were placed inside the color wheel, each of the corners of the box would touch upon a hue. These hues touched form a tetrad. Like a triad, each hue must be an equal distance from one another. A tetrad will always consist of one set of complements made up of a primary and a secondary hue, as well as two intermediate hues for the second pair of complements. Of all the colorways, the tetrad offers the artist the greatest range of hues and contrast to work with. Van Gogh used this color scheme to great effect when he painted this night cafe scene. He uses the warm colors versus the cool colors to create this luminous nighttime scene. Finally, variations on a single hue are used in a monochromatic color scheme. The advantage of this system is a high level of unity as all the colors are strongly related. One of the disadvantages of this technique, however, is the lack of variety. These are typically created by using variations of a hue in a value set. Color interactions refer to the way colors influence each other. Colors are never seen in isolation. Colors can always evoke psychological reactions, evoke memories, demand comparisons, or are even affected by lighting and the colors they exist with on their surface. The effect of coexisting colors interacting is called simultaneous contrast. Three principles of simultaneous contrast are shown here. Light-dark contrast is shown in the first pair of images. The blue-green square appears much lighter than when it is placed on a black background. A complementary reaction is shown in the second pair. The same blue-green square appears to glow when it's surrounded by the red rather than the neutral gray. In the third example, the same blue-green square appears almost green when it's surrounded by a solid blue, yet it can appear almost blue when surrounded by green. In this illustration of two forms of simultaneous contrast, a neutral gray is placed on two complementary backgrounds. The gray square seems to be completely different depending on the hue of the background. In the bottom example, The same red hue as seen in the stripe below it is placed on contrasting red backgrounds. Although they are the same color, the red square appears to be very different in each. Colors can also be changed by the context of their frames. If a color is seen against a black outline, it frames the hue and constrains its visual presence, as if the black frame is holding the hue in and compressing it. However, if the color is viewed against a white outline, the hue seems to visually expand into the area. Even though the white boundary isolates the hue from the background, it allows the color to visually swell in its space. Closely related to simultaneous contrast is the concept of value contrast. One of the easiest ways to change the look of a color is to place it on a contrasting background. Colors may appear very different depending on the background they are placed onto or next to, as seen here. Placing a hue on a dark background isolates it and makes it appear lighter. It also makes the lighter hue appear larger. Conversely, placing the same colored hue on a light background makes it look darker and smaller. However, there's no reaction if the background and the foreground colors are of equal value. There must be contrast between hues to achieve this effect. The Bezold effect demonstrates the profound influence of color interaction. This effect means that a change in a single color can substantially alter our perception of an entire pattern. In this example, the background color goes from gray to red and adds in electric energy to the design. On a light green background, the darker shapes are accentuated while diminishing the brightness of the orange shape. A dark blue background creates a strong contrast and value and pushes the orange and yellow shapes forward. The compositional impact can be substantial even when the amount of color is small. Color interactions become especially dramatic when complementary colors such as red-orange and blue-green are used in a composition. In the human eye, two types of cells known as rods and cones are used to distinguish hues such as red and blue. According to opponent theory, the cones can register only one color in a complementary pair at a time. This constant shifting between the opposing colors creates a visual overload at the edges of the shapes, resulting in an electric glow. This color theory overview concludes Module 2.1. We will continue with more material explorations in Module 2.2 and 2.3. This is just to give you a basic overview of basic color theory. Please refer to the PDF of this slideshow on Canvas if you need to slow down or revisit some of the information.